think I did a long
Yeah.
time ago.
Actually, I like that. I ran it with a TurboMaster, and that's 4 megahertz, and to me that was just perfect, right? If you could get a machine that runs at 4 megahertz. And I've heard reports that it runs well with the Chameleon. What's the speed of that? Does anybody know? Chameleon, is it 8? I don't know. Anyway, super CPU, outside of the fact that you can't get one for love or money, I think it's overkill. So why do I say you need fast disk to run GEOS? The reason, again, is memory. 64 kilobytes of memory and doing all the things that I listed in that feature list before, that's a stretch. So what GEOS does is it constantly swaps out little bits of code and data to the disk in order to be able to run all this stuff. Some of the things that cause disk access. Font changes. There's a system font that's always in memory, but any other time you want to load a font, it's got to come off the disk. Program overlays are a big one. All of the major GEOS apps, like GeoWrite, the word processor, suppose you want to make a tab stop. You click on the ruler to drop a tab stop. If you notice, there's a little disk access because it's got to load the code to do it first. Or if you click on the big M to drag the margin somewhere, there's going to be a disk access because it's got to load that code in first. Or in GeoPaint document, if you're looking at a GeoPaint drawing, as you scroll through it, every little bit of that document is stored in a different place on the disk, and it's got to come off the disk. Or changing a paint tool in GeoPaint, it's going to load it off a disk. VLIR documents, like I said, when you're scrolling through a GeoPaint image, the reason that takes so much disk access is because every row of cards, 8x8 pixel blocks, every row of cards is stored in one chain of disk sectors.
What's VLIR?
Huh?
What's a VLIR document?
I was going to talk about that later. Okay. VLIR is a special kind of file that GEOS uses. It stands for Variable Length Index Record. You know how normally on a Commodore 64 you've got the directory entry, which points to the first sector of a file, which in turn points to the second sector, and so on until you get to basically an end of file marker. Mm-hmm. So you have the directory entry pointing to one long chain of sectors that makes up the data. In the case of a VLIR file, which is something that GEOS came up with specifically for stuff like this, you have the directory entry pointing to a single sector, but that sector can hold up to 127 track and sector pointers, each one of which points to a chain of sectors with data in it. So for example, in a GeoWrite file or a GeoPaint file, every row of cards in the graphics data is stored in one chain of disk sectors. So you want to scroll up a little bit, it's going to say, oh, okay, where's the next one? It goes out and reads that chain of sectors off the disk, puts it into memory. Another good example is a GeoWrite word processor file. Every page in a GeoWrite document is its own VLIR chain. So you're essentially doing the equivalent of loading a file every time you change pages in a GeoWrite document. Cut and paste. When you cut and paste in GEOS, you're not doing it to a memory buffer. There is no memory. It's all used up. So when you cut, if you hit Commodore C to Commodore C to copy or Commodore X to cut some data in a GeoWrite document, guess where it goes? It goes to a disk file named text scrap. Same thing with an image, photo scrap. Then there are the infamous desk accessories. The desk accessory is a small program that can be run from inside of another program. And when GEOS loads one of these, what it does is, and I'll show you one of these later on, what it does is it says, okay, it's going to load here, it's going to use this much memory, and it basically carves out a hole in whatever program is running, takes that memory, swaps it out to disk, loads the desk accessory in its place, saves the state of the system, runs the desk accessory. When you're done with it, loads that memory back off the disk, restores the state of the machine, and picks up where it left off. So again, a lot of disk access. In fact, almost everything you do in GEOS causes disk access. That's why the most important thing you can do to make GEOS happy is to give it fast disk. So what does it mean, fast disk? There's one that's not on here, and Elif is going to correct me when I get that part, but the fastest thing you can do is to use a RAM disk. Problem with that, of course, is that you have to copy the data onto the RAM disk at the beginning of your session, And you have to remember to copy it back onto a real disk, a physical disk, when you're done, otherwise it's gone forever. In the old days, when there were a lot of people using GEOS and a lot of GEOS power users, the sort of canonical solution was to have a CMD hard drive. How many people have a CMD hard drive? I see 1, 2 hands going up. Okay, so that's another thing that people just don't have anymore. But that was a great thing to do with GEOS. The CMD hard drive, of course, this is the day in the days before most people were using image files all the time. But the CMD hard drive had up to, what's the limit, 254 partitions on a drive. And those partitions could be, for example, a 1581 emulation partition. And you could switch between partitions just as easily as you could take a 3.5-inch floppy out of your 1581 drive and put a different one. There was actually a nice app for that called CMD Move, I think. It's really nice. So okay, RAM disk is kind of hard work. CMD hard drive, nobody has them anymore. We were talking about Super CPU before, nobody has that anymore. This is sounding out not to be a very happy story. But I found, personally, recently that there's another really good solution, and that is something that we all know about, Micro IEC, or SD2 IEC. And I was telling some of the guys before, I had the first model of Micro IEC when it first came out, when James first started selling them. This is the one with the CF card in, which is, you know, huge by today's standards. And I never did that much with it because I know at the beginning it didn't support GEOS and so forth. And then just a couple months ago, I picked up the latest version of a Micro IEC. You can see I've got one hooked up here. And I was just stunned. I thought to myself, you know, I'm going to try and create a bootable GEOS image on here and see if I can get it to work. And it's just almost perfect. There are a few minor quibbles, but it works really good. And I'm going to show you an app that I wrote today called Micro IEC Switcher that allows you to do essentially the same thing that that CMD app did. You can switch between D81 images while you're running GEOS. So Micro IEC is a really good way to run GEOS if you're interested in learning how to get started with it. And I do say I think you need a RAM expander anyways. You can run it without, but there are some drawbacks there. One is that, like I said before, only one font can be in memory at a time. Also, GEOS uses disk drivers, and only one disk driver can be in memory at a time. And where they're loaded from is the GEOS configuration program, which oddly enough is called Configure. But Configure is a VLIR application, and some of those VLIR chains are actually disk drivers. So if you change drives, you switch to a different drive, and it's of a different type, like a 1541 or a 1581, excuse me, it's got to load that disk driver off of the disk and bring it into memory. But if you're using an REU, it caches all the drivers you're going to need right at the beginning and puts them in the REU and just DMEs them in when you need them. Second good reason to have an REU is that there's an API in GEOS called Move Data, which is a generic move some data from here to there API. And if any of you have ever written one of those, you know that the problematic thing is that you have to check for overlap and make sure you don't make a mess. If you have an REU, GEOS will do that with the REU. It'll say, the programmer will say, I want to take some memory from here, I want to move that block of memory to here, maybe it'll overlap. GEOS will say, well, you know what, it's actually going to be faster to take that whole block of memory, push it up into the REU, and DME it back at the place it's going to go again. So even though it's doing 2 copies, it's much, much faster than copying it all in main memory because, as we know, the REU uses DME. Another good reason is the entire operating system actually is stored in a RAM expander. It takes one 64K bank and stores the operating system there. In fact, what I was going to do for the beginning of the demo, I was going to boot GEOS from Micro IEC. I'm actually going to just type sys49152, and if the demo gods are with me, it'll just fire right up because the operating system is still in the REU. The other reason you need an REU is for GEOS programming, because GEOS, I'm not going to spend a lot of time talking about programming for GEOS, but there's a really superb, unbelievably good symbolic debugger for GEOS called, guess what, GeoDebugger, and it's almost useless without RAM. So how do I install GEOS? you know, you may be able to get your hands on an original copy of GEOS, and if you're you know, a historian type like most of us are nowadays with these machines, you may want to do it that way. But there are reasons not to. First of all, the original was just viciously copy protected, and also it was keyed. You could, the first time you used any of the standard GEOS apps, it would key that app to the copy that you were running under, and you couldn't run it on any other copy of GEOS. So there are all kinds of reasons not to do it the original historic, you know, conservative, or what do they call it? I'm thinking of in the museum where the guys wear the white conservative gloves, you know. It's, you don't want to do it that way. You want to boot it from a cracked copy, or better yet, you can take a snapshot of a running system, and there are a couple programs that will do that. One is called Geo Make Boot. I think that was done by the people who did Maverick. And there's another one that actually was written as part of the patches, part of a series of patches for the master adapter for the Schneider Turbo Master. And I took that guy's code and put a GUI on the front of it and made a program out of it called, what did I call it? GeoSnap. GeoSnap, because it makes a snapshot of GEOS. But the cool thing is, you can take all of the GEOS kernel as it's in memory and, you know, move it around a little bit and then put it to one gigantic disk file. Well, not gigantic, but fairly large. And then you have a loader that'll take that big memory image, plop it back into memory, shift it around a little bit, call an initialization routine, and bam, you're good to go. The reason that's such a good idea is that most of us have Jiffy DOS nowadays. So instead of going through the standard GEOS boot mechanism where it's going to load sector by sector, you know, and do the copy protection check, which has been no cracked copy and everything, instead you just let Jiffy DOS load this big block of stuff into memory, and poof, you're done. I would say start, if you're going to start playing with GEOS and you want to learn a little bit about it, start with one drive on device 8, just so you can figure out how everything works, make sure everything's working before you get going. And then run the program called configure to set up your drives. Again, learn the basics first. I've seen people, there was somebody in IRC recently, I don't want to pick on anybody, but he said he wanted to start with wheels. Okay, so he was running wheels, and he goes, yeah, I can't get it to run. I said, well, okay, how's your system set up? Well, I've got this on drive 8, I've got this on 9, I've got this on 10, I've got this on 11, then I've got something on 12, 13, you know. I was like, that's not going to work. Well, what do you mean it's not going to work? GEOS makes some assumptions about your machine. And one of them is that there are only 3 drives. Okay. A, B, and C corresponds to 8, 9, and 10 on the bus. Okay. And it likes to boot from 8, but if you're going to use one of these snapshotted copies, you can get them to boot from 8 or 9. The reason it has to be one of those 2 drives is that drive C is never active. It's for swapping the other 2. And I'll show you that when we see the desktop. Don't have anything set on device 11. The reason for that is, if you take drive C and swap it with drive B, he's going to make one of them 11 temporarily to do the swap. That's why you should never have device 11 on a GEOS machine. And if you don't have, like I said before, if you don't have a RAM expander, you're going to need to put a copy of configure basically on every one of your GEOS disks, because it's going to need to load the disk drivers from there. And you also always need to have a copy of the desktop, which is the GEOS shell. How many old-time MS-DOS users do we have who used it in the old days? Come on, I know there should be more hands on that. Who remembers the error message, bad or missing command.com? Mm-hmm. More people than have used MS-DOS. Okay. That's because it can't find the shell, and it's got to reload the shell to be able to load more programs. The same thing will happen with GEOS. You'll get the infamous dialog box that says, please insert a disk with desktop 1.5 or higher. I think that's how it's worded. And sys49152 is your friend. Like I said before, GEOS actually will stash itself in the RAM expander if you have one. And if you make a mistake and it won't boot or whatever, you've painted yourself into a corner with device numbers, you can just go back to basic or even reset your machine as long as you don't power down. And then type, make the changes you need to make to your disks, and then type sys49152. Voila, it'll come right back. And then a little bit about the file system. I talked about this before. The file structure is different, VLIR, but it does use the same low-level format on a floppy disk. So if you have a floppy disk that was formatted under Commodore GEOS, it's good to go for GEOS. The only differences are that GEOS adds data in places that are not normally used. So for example, in the directory entry, in a standard Commodore directory entry, like on a 1541, there are bytes that are just blank, they're unused. And GEOS will use those, for example, to put a flag there, is it a VLIR file? To put the date and time stamp, to put the GEOS specific file type there, like is it application data, is it a program, so on and so forth. So it's okay to put non-GEOS files on a GEOS disk, but the one thing you must never ever do is to validate a GEOS disk from Commodore BASIC.
Is that what happened to all those discs?
Huh?
Just joking. I said, is that what happened to all those
That,
discs?
yeah, that's what happened to all those disks, right? Because, for example, one of the unused bytes in the directory that GEOS uses is a track and sector pointer to what's called the info block of the file, which contains the icon and some other information about the file. Well, standard Commodore DOS knows nothing about that sector, right, or that place in the directory entry. So if you validate it, that sector now becomes fair game, and some other program can write over it. Same thing with VLIR files. Think about what I said about how a VLIR file is structured. You have all these different chains of data, but they're only listed in one place, which is a single track, which is a single sector containing a list of pointers to all the chains. So if you validate the disk from Commodore DOS, you're going to have a file with one sector in it, and everything else is marked as free. So that's like the #1 rule to be careful of with GEOS. Okay, it's demo time. I'm going to show, actually I'm not going to show a whole lot of the GEOS apps. I was going to show GeoCalc, but I don't have any spreadsheets. The only GeoCalc spreadsheet I have is the one that I use to track my stock options with GEOS. So I'm not going to show that. I've got a website for those that don't know, lionlamps.org. It's not hard to find the Commodore stuff. Just click on the Commodore chicken head. There is a very sparsely used GEOS channel on NewNet. So for those of you that are in C64 friends, if you want to talk about GEOS and you don't want to frighten the children, you can go on this channel. I also just started a Google News group called Commodore GEOS. So if you have some questions that you want to ask there, then you can't stick around in IRC or whatever, that's a good place to do it. And also a lot of the old magazines had good GEOS articles. In fact, there were some GEOS specific magazines. I've got stacks of them at home, I can never remember which or which. But my favorite articles are the ones that were in Commodore World. You get some of the articles from some of the guys at CMD. Morris Randall even wrote some good programming articles in those. So that's a good resource to use. Does anybody have any questions about GEOS or how it works before I go ahead and see if my machine will start up?
You mentioned the freeze technique or the GeoConfigure. Was that, how did that differ, other obviously than not having hardware, or could it be done with like an action replay or snapshot? Or those other cards where you could freeze state and save it to the disk?
I don't think it'll work with something like a super snapshot.
I'm trying to remember. I had an action replay 4 and I think it never worked with GEOS.
Yeah, and I think the reason it doesn't is that GEOS, you know, like I said at the beginning, it not only runs in 64K of RAM, but it completely resets all the chips, the CIAs and all that other stuff. So I think that kind of stuff is kind of hard to, some of those registers are read-only and stuff.
And the card's not thinking about saving the state of those things,
yeah,
rather
well,
than just memory contents.
It's difficult or impossible to save the state of some of those.
Yeah.
Okay,
Lose
so...
just
I'm
to
sorry,
follow
go.
on that, you'd also lose the disk speeder because the disk state wouldn't be.
Right.
Well, that's
This one
another
wouldn't
good
be
reason,
saved.
right? It wouldn't be able to start up because the turbo code wouldn't be down in the disk drive. Right. Yeah.
Because GEOS load stuff into the
Right.
floppy.
Normally, as we know, the Commodore peripherals were intelligent devices. They had their own RAM and ROM, and the buffers for reading stuff off the disk were inside the disk drive. GEOS takes those buffers and fills them up with code, speeder code, and
Gotcha.
puts buffers inside the machine from 8000 to 84FF. Okay, so let me switch over here if I can, and we'll see if we can make some magic happen. Ooh, that's a good sign. Right, let's see, I'm not going to need this mouse. Let's put this guy down here. get real operating system on here. Oops.
Does Jiffy DOS have any effect on GEOS?
Not once it's running. Like I said, if you've snapshotted it into one giant file, the load time, the initial load time of it is going to be appreciably faster. Oh, sorry. But once it's running, no, because it uses disk speeder code and everything.
I figured that's what it was. That was the case. I just wasn't sure.
So I booted GEOS before just to make sure, to hope everything was going to work. And I want to demonstrate that reloading from the REU. He leaves a hook at this address, and if you've had it running and had to drop back to DOS for any reason, all you got to do is this, and it sucks the operating system back out of the RAM expander, reinitializes the chips or whatever, and boom, you're good to go. So let me get my Mr. Mouse here. But I want to show you that loading it from scratch is also really fast on a Micro IEC. So right now I've got a CMD hard drive set up as 8 and a Micro IEC set up as 9, and then I've got a 512K RAM expander in here. So I'm just going to load, well, let me show you the directory. So GEOS is nothing more than a quick stack auto boot program, and then turbo boot that 85 block file there. That's the snapshot. It's not compressed. It's a snapshot of GEOS, which gets loaded into memory by that GEOS file, and then there's a little loader on the front of that turbo boot program. Passes control to that, moves some stuff around in the memory, and then does what it needs to do. So we'll see how nice and fast that runs. So you can see it loaded it into memory really fast. Oh, actually that's the initial loader doing that, but that's good. And there it is. So those of you who remember running GEOS in the old days and loading it off of 1541 or something, you know, you can sit there and wait and wait and wait. Okay, now it's ready. Now I'm ready to do something. So this is the desktop. This is the GEOS shell right here. And I have it set up with, like I said, a CMD hard drive on 8, Micro IEC on 9, and a RAM drive here of 1571 size as drive C. So we can't see drive C, we can see drive A. There's my hard drive. Now compare the time it took to load and display that with the time it takes to load and display the Micro IEC. As fast or faster, I would say. So it's a really good option. You don't need to have a hard drive that you can't get anyways to run GEOS nowadays. And of course this one is not an active drive, but if we want to switch this, for example, with drive A, we move it like this. This is called making a ghost. You click once and you make a ghost, you drag it where it needs to be. Imagine that, drag and drop on a Commodore 64, right? And of course this is an empty disk because I haven't copied anything up there yet. So I'll just show a little bit about the desktop. For those of you that already know GEOS, this is going to be kind of boring, but if you notice there are 8 files there, so very clever here. You're actually looking at one sector of the directory. So, and then here's this little turned up edge over here. You can click on that to go to the next page of the directory. You can see some more stuff here. There's a program, and there are also all kinds of shortcuts you can use. For example, I want to go straight back to page 1 without paging through it. I can just type 1. It takes me back to page 1. In fact, if you want to know about those shortcuts, there's an option here that lists them, and there's about 1 million of them. And this is really helpful stuff. All through GEOS, there are a lot of keyboard shortcuts that will help you use it faster. We can see here some of the different types of GEOS files. Configure is the one that you use to configure your drives when you first start GEOS, but that's also an auto exec because it starts up when the system starts up to read your last saved configuration and know what drives to go out there and look for. That's why you should always start it from the same configuration that you last saved. Otherwise he's going to look for one kind of drive on drive B and find something else, and he's going to get all confused. and it may not start. That's a common mistake that people make. So these are auto exec files. They start when the machine first starts up, and that doesn't look right here. I think because I restarted using the sys command. No, I didn't. I'm not sure why this didn't do what it was supposed to do. This is supposed to read the time off the real-time clock inside the CMD hard drive, so it should come right
Brian,
there.
I think when you restore from REU, I don't think it lets your auto-execute programs.
Yeah, there
Okay.
is.
But why it didn't do it when I just double-clicked, I don't know either. So.
The time is right there.
That's just the icon.
Oh, it just changed. Okay, there we go.
Yeah.
All right. So yeah, I think you're right though. I don't think it reruns the auto execs. Okay. So here's some. Another thing you can do is there's a preferences editor where you can change the color of the icons for each file type. So blue is applications, red is system files, and I don't think I have any fonts here. Green is the desk accessories that I was talking about, where it'll actually swap out the memory that the desk accessory is going to use. So let me go now and show a little bit of the apps, including the one that I just wrote that I'll put on my web page. This is it. It's called Micro IEC Switch, and there's the source code too. I'll be releasing the source code. So if we want to switch to a different, actually I don't think I showed. Let me drop back to basic again. I can show that same technique, and we'll look at drive 9. And if I go back one, you can see that I have a whole pile of D81s here. Those test ones were just long story. Anyway, these are the good ones near the top. You can see there's a whole bunch of D81s there. I'm going to go back inside the one I was inside just a minute ago. And restart GEOS like this. Okay, and I know that this program